This is 2017, paper 1, question 9. It's a question on trigonometry, in particular on trigonometric graphs. So we're given this function here, ft, and ft represents the depth of water in a harbour, and it depends on time, and time is given by t, where t is the time in hours from the first high tide. And we're talking about a particular day, Saturday in this case. Now, also be careful throughout the question that the angle is in radians. Now, we're also given extra information here on the Saturday. The high tide is 5.5 meters and the low tide is 1.7 meters. So we can fill those in on the graph. So high tide is 5.5 and low tide is 1.7. So that's down here. That's 1.7. Also, we're told that high tide occurs at 2 o'clock and at 14:34. So we can also fill those in. So this is the 2 o'clock here. And the other peak is the next high tide, which is, we're told, 14:34. Now, what we're asked to do in this question is to label and scale the axes. So if we try and do that next, we need to find a scale here that suits. So we're starting at 2 here. So let's count these boxes. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, 13. So that fits perfect. It's obvious that the scale used here is one box represents 1 hour. So we can now trace backwards as well. If that's 2, that's 1, and that's 0. So this is 0 hours here, or midnight. Now let's do the same on the vertical axis. So let's try 2, 3, 4, etc. That's 2, 3, 4. That doesn't work, obviously, because if you go to 5, 5.5 is too far away. So let's start again. So maybe try this one as 2, and that's 3, 4, and 5. And now we have it. That seems to fit perfectly. So we have both. We have a scale for both the horizontal direction and the vertical direction. Now to put in our axes, we can trace back here on the vertical axis. So if that's 2 above here, this must be 1, and this must be 0, a depth of 0. And now we can see where the two zeros intersect. So if we go across here and go up here, we see that this is the 0, 0 point, or the origin of our graph. So now we can draw an x and a y axis, or in this case, t and ft. So let's try and draw a straight axis from there, so we'll straighten that up. So from there, that's now our x-axis, or our t-axis. So time is measured in hours. And we can do the same vertically. So vertically we have through here the ft axis. So that's ft, which is the depth of the water, and that's given in meters. So that's the graph completed. That's the scaled axis and the labeled axes as we were asked. Now, one important point here before we move on is this. We have to be careful with this time, because time, t is the time in hours, it says here, from the first high tide. So the first high tide is very important. So that means the time is 0 at the first high tide. That's where it all starts. That's how we start our timer for this question, as it were. So right here, at high tide, that's where t equals 0. So let's distinguish that from the time, from when the hours are actually 0, at midnight at 0 hours, which is the 0 down here. Now we can move on. Before we start the next part, we're going to have to go back over some of the theory about trigonometric graphs. And so let's look at our function again, which is ft is equal to a plus b cos ct. And we're going to build that function up step by step to see what happens at each stage. So we can do a table here. So for example, ft is the first column, and we'll do the period and range for each. make that a heading, and some columns down here. Now start off with the most simple function, the most simple of cost functions, which is just simply cost t itself. And the period of that would be 360 degrees or 2 pi. It repeats every 2 pi. And the range is -1 to 1 vertically. So that's the most straightforward cost function. Now let's build it up gradually. Put a b in front, like we have here, and see what that does. So b cos t. Well, the period is still 2 pi. That doesn't change. What that b does, let's say if it was a 2, for example, first, 2 cos t, that would stretch the function in the vertical direction by 2, so the range would be -2 to 2. Or if b was 3, it would be -3 to 3. So generally speaking, that b, what it does is it stretches the range, and the range becomes -b to b. Okay, so that's the b taken care of. Now, what does the a do at the start? So if we add on an a, well, if you add on an a to any function, that just changes the y value. It moves the whole function up a places. So for example, if a was 2, it moves the whole function up 2 places in the vertical direction. If a was 3, it moves up 3 places, and so on. So, and the period doesn't change as a result, that stays the same. So what happens is each of these here, the -b moves up a places to -b plus a, and so does the b. So the range has changed to -b plus a and b plus a. And finally, what does the c do here? So let's put that in last. So a plus b times the cos of ct. Well, what that does is it takes the period and divides by the number in front of t. So again, for example, if that was 2t, the period goes from 2 pi to pi. If it was 3t, the period becomes 2 pi over 3, etc. So the period now becomes 2 pi over c. And it doesn't change the range this time, so the range stays at -b plus a and b plus a. And that's exactly the function we have in this question, a plus b times the cos of ct. So let's put a box around that, because that's the one we're going to use for the rest of the question. So we're going to have to recall this in the next part, the fact that the range is -b plus a to b plus a, and the period is 2 pi over c. So now we're ready to move on to the next part. So again, in b part I, find the function itself is ft is equal to a plus b cos ct. And the range, as we've just seen, for this function is -b plus a, b plus a. But we also have the range from part A of the question. If you go back and look at our graph again, the range is from 1.7 to 5.5, as you can see there. So that's low tide to high tide, 1.7 to 5.5. So that's 1.7 to 5.5. So now they match up, and we get two equations. -b plus a is equal to 1.7, and b plus a is equal to 5.5. Now, so these cancel, -b and b cancel, and you have 2a is equal to 7 and 5 is 12, carry the 1 and 5 is 6, and 1 is 7. So a is, if you divide by 2, you get 3.6. Now fill that back in. Take b plus a is 5.5. So b plus 3.6 is equal to 5.5. b is equal to 5.5 minus 3.6, which is 1.9. And that's b part I done. We have a and b now. Now the next part, show that c is 0.5. Well, we also know at this stage that the period of our function, we just worked out there earlier, to be 2 pi over c. And we're looking for c this time. We also know, of course, if we go back to part A, what period is, what the answer is, because if you go here and look closely again, you can see that from high tide to high tide, that's the period, that's where it repeats itself. So we see from there to there, from 2 o'clock until 14:34, that's a gap of 12 hours and 34 minutes. So that's the period of our function. So that's equal to 12 hours and 34 minutes. Now we must convert that to decimals because we're told we need the answer to one decimal place. So we need to convert those minutes. So that's equal to 12 hours, and 34 minutes is actually 34 out of 60 as a fraction. So it's 12 and 34 sixtieths. So we'll just fix that there. So it's 34 sixtieths. Now, so we have a new equation. 2 pi over c is equal to 12 and 34 sixtieths. So we can rearrange that formula, bring the c across, and we now have 2 pi over 12 and 34 sixtieths. And if you work that out, you actually get an answer of 0.499. And to one decimal place, which is what we were asked, one decimal place is just simply 0.5. And that's part 2 done. Now the last part, ft, again the function write it down is a plus b cos ct. But of course we know what a, b and c are now, so a and b first of all above are 3.6 and 1.9. So that's 3.6 plus 1.9 times the cos of 0.5. We've also worked out that in the last part, c, 0.5, 0.5t. That's ft. Now, if we read this part carefully, we're looking for the height is 5.2 at a certain time, and the height or the depth of the wave is given by ft. So we'll work with that bit first before we address the rest of the question. So we're looking basically for the time when the height is 5.2. So that's 5.2. So that's the height or the depth of the wave. And now we can actually work that out by bringing the 3.9 across. So it's 5.2 minus 3.9 is 1.9. So just check that. Sorry, it's 3.6. Just to fix that, that's actually 3.6, not 3.9. So that's 3.6. And so it's equal to 1.9 cos 0.5t. Okay, so 5.2 minus 3.6, that gives us 1.6, and 1.6 is 1.9 cos of 0.5t. And now we can divide across. So we have 1.6 divided by 1.9 gives us the cos of 0.5t. And that's 16 over 19, same thing. And now we can get 0.5t by getting the inverse cos in our calculator. So 0.5t is equal to cos minus 1 of 16 over 19. And if you work that out, now we've got to be careful at the start of the question, just to remind us of something here. It's very important to remember the angles are measured in radians. So CT is measured in radians. So we have to work in radians here on our calculator. So if you work that out on your calculator, you get 0.5t is equal to 0.5696. And we can work out t from that. So t is equal to 0.5696 divided by 2 divided by 5, and you get 1.139, and that's the time in hours. So time is always in hours in this question. Okay, so just to finish off this little bit. So at this stage, we've now established that the time is equal to 1.139 hours. But we're supposed to work things out in this part in minutes. So we have to just adjust that slightly. If you work that out in minutes, time is equal to 1 hour. And if you get the 0.139, multiply by 60 to get the answer, you get 0.139 and multiply by 60, you get 8.34 minutes. Okay, so that's the time. Now, what does that time stand for? Well, so far in the question, all we've done is we've put the height equal to 5.2 and we've got the corresponding time. So the time is 1 hour and 8.34 minutes. Rounded off to the nearest minute. It also says the nearest minute, so that's just simply 1 hour and 8 minutes. So that's the time when the height is 5.2 meters. So let's go back to the graph and get the significance of that in the context of our question. So 5.2 meters after 1 hour 8 minutes. Well, every box in our graph is an hour, as we said. T is not at 2 o'clock. So where is 1 hour 8 minutes after that? So 1 hour 8 minutes is just along here, someplace just slightly bigger than one box. So if we go up here, that's where the 5.2 is. 5.2 meters. So that's what we have worked out so far. But that's not quite what we were asked. If you go back to the question, we were asked to find the times on Saturday afternoon when the depth of the water is 5.2. So you see there are other times when the depth is 5.2 as well. And if we go back, we can see on our graph where they are. They're here. So this is the afternoon part. This is 14:34, which is the afternoon. So by symmetry, there must be a 5.2 there and a 5.2 there as well in the afternoon. Don't forget the peak up here was 5.5. So these are the times we're after. These times. If we bring these down basically to the time axis, the horizontal axis, and get those two times at either side of 14:34, that's what we're after, those two times there. And of course, that's 1 hour 8 minutes each side. So all we've got to do now is add and subtract 1 hour and 8 minutes from 14:34. So if you go to 14:34, so 14:34 plus or minus 1 hour and 8 minutes. That's going to give us the two answers we need. So let's do that to finish it off. So 14:34, if you add 1 hour and 8 minutes, first of all, you get, we'll subtract first, maybe get the lowest one first. So 8 and 6, 14, carry the 1 from 3 is 2, and that's 13:26. And now add the 1 hour and 8 minutes as well. So it's 14:34. And if you add 108, you get 8 and 4 is 12, 1 and 3 is 4, 14 and 1 is 15. And they are the two answers, 13 hours 26 minutes and 15 hours and 42 minutes. And that's the end of this question.